Hello and welcome to the 6th episode of the Green Sofa Dialogue. Today I'm joined by Frauke Thies, Executive Director of Smart N. Hello, Frauke.
Hello.
And Johannes Kunat, Product Manager at Thermondo. Hello, Johannes.
Hi there.
And thank you both so much for joining me today. I think for the first time we have two guests who are both German speakers, native German speakers. But I wanted to ask you both, where are you right now? Frauke, why don't you go ahead?
I'm actually in my home very close to Brussels.
Okay.
I think nobody's working at the office in Belgium at this point.
Yeah. And Johannes, where are you?
I'm also at my home. As you can see, it's not green, but we do have a sofa and we have a little bit of greenery in our back in Berlin Mitte, so or Friedrichshain.
Ah, okay, yeah.
Actually, right on the former Grenzstreifen, so right on the border. There used to be the wall right below me, and well, now there's a new building.
I mean, I really want to ask you what street you live in, but for data privacy, for privacy issues, I won't ask you. But we are also coming to you from Berlin Mitte. Why don't we go ahead and dive right into what we came here to talk about today, which is digitalization. I want to ask you both first. I have a couple of notes. I have these buzzwords: smart homes, smart buildings, and smart factories. What does this mean, and how does smart energy management work?
Maybe Frauke is the best person to answer this very rounded question first.
Okay, yeah, sure.
Push the ball to your side.
Yeah, good. I can have a go. So I think looking at it very broadly, it means optimizing all the assets that there are in a home, in a building, in a factory, be it generation, be it storage, be it demand assets, to optimize them both for maximum comfort and efficiency within the building or the factory, but also to interact optimally with the energy system that's happening around the building, and for instance, offer flexibility when this is what the system needs, or providing energy to the system when this is what the system needs. And this may maybe sound all a bit cluttered when I describe it so theoretically or abstractly, but I think there are a lot of really good concrete examples out there on how buildings or factories or homes are doing it. And maybe to start with one that I always like referring to is a shopping center in Finland called Cello. And they have some 170 shops in this big shopping center, big mall. And what they've done is basically they have self-generation, in this case in particular through solar PV. And they have automated all their heating, ventilation, even their lighting. They also have storage on site. And they have a microgrid connecting the entire system. And what they're doing is they're optimizing, obviously, inside this whole shopping center to make sure that the temperature is always within the right range, to make sure that the lighting fits, and so on, and to make sure that the own on-site generation is optimally used. But they also interact with the wider Finnish electricity network. And in this case in particular, they are providing flexibility to Fingrid, so the Finnish transmission system operator. And they even, are paid for providing this flexibility to the system. I think it's around 480,000 euros a year that they just earn by providing this flexibility to the balancing market. And now, of course, you can imagine this case going further if there were also price signals coming from the wholesale market and not just from balancing. Then this shopping center could interact even more with the energy system and make sure that it's not only optimizing on site and reducing, minimizing, or even eliminating its carbon footprint on site, but it's also helping an energy system that is increasingly based on renewables and is increasingly variable by providing the flexibility that's needed to balance. So that's a commercial example. I guess Johannes may have more on the residential side, and we can also come
Maybe
back to
and
industrial.
just for this one example, just one note, maybe we wish we had this in the building area for private houses as well, but actually a huge problem that we have there is on the policy side that for a lot of cases where you produce for example, you have a photovoltaics plant on your home house and you produce electricity and you want to sell it to the grid when somebody else is needing it, or you want to use it when you don't need it. But because sometimes if you have a battery, it's still counted as a consumer. You have to pay for the electricity fees for the electricity grid. This way, you don't really have an incentivized to stabilize the grid. Plus, we're only starting the smart meter rollout this year, which basically means only now we know where the electricity is flowing and where we need it to stabilize the grid. And I think generally to that question, when we talk about the energy market on a whole, I think digitalization has the power to marry demand and supply, to bring those factors closely together. Because, I mean, this is in the end what a market function is at its core, bringing supply and demand together. And digitalization helps make that as precise as possible. So at some point, if we need electricity, we can produce it at the same time, and suddenly if we don't need it anymore, we can shut this electricity off or put it somewhere else. Yeah. You could say a lot of other examples, but smart energy systems is very rough. You can see it everywhere, basically.
I want to come back to what you said about the policy side of things. If you had your druthers, how would you modify the policy framework to make what you're talking about happen more quickly?
Well, one aspect is I'm not sure where we exactly are right now because the debate is changing very fast now, also on the policy level. But if you produce decentrally renewable energy through a PV or through a photovoltaics or through a fuel cell in your home, and then you save it in a battery, in your own battery or in your car, and then if you don't need it, you want to sell it to the grid, which helps stabilize it, you should not have to pay. If you consume it yourself, you should not have to pay the fees for the grid. And you should not have to pay the fees for the grid, the so-called EEG-Umlage. It's the renewable surcharge that in Germany most consumers have to pay for the renewable subsidies. So all this leveling out, there's still a lot of things that have to be changed. And I think we have a new like EEG law every 2 years or something. So there's always changing something. But I think on one of the most important policy measures that we need, we already implemented with the climate package for the building industry, which uses about 40% of energy in Germany or even in Europe. There we need to unfortunately subsidize the replacement of very old, inefficient technologies such as oil or coal and replace it with somebody new. Because unfortunately, prices are still the main aspect for customers or for consumers to change something, to invest in something, especially with heaters and technology. They just cost a lot. And if you don't do it now, they're going to buy another gas heater or oil heater, and they're going to keep that for 10, 20 years. So you have this lock-in effects that are very dangerous. If he has an oil heater for the next 20 years, it's impossible to reach our 2030 goal. So we're going in the right direction. And one more thing that I'm looking forward to in Germany is finally we have a CO2 price next year starting. So in a few months, there will be a CO2 price of 25 euros. And that means that in German, we call it Verursacherprinzip. So the principle of polluter pays. This is a key thing in policymaking when you talk about environmental policy or climate change policy, I think. That whoever pollutes something should pay for it. And the CO2 price per ton will move that in the right direction, I think.
I think so. Go ahead, Frauke.
Yeah, I think maybe picking up where Johannes started on on the regulatory context, because I think what he described for Germany is very much true for Europe, and to a very large extent even globally, that when we look at the whole energy transition, initially the incentives were very much to scale renewables, to feed them into the system, and to not care about how this was done, to not optimize on-site or anything else. The rest of the system would absorb it. And then we've moved into, knowingly or voluntarily or not, but into an era that we're in now, which is mostly about, you are encouraged maybe to optimize on-site, to self-consume as much as possible, because that allows you at least to save electricity purchases from the grid that can be expensive, because you pay not only the electricity price, but taxes, charges, whatever else on top of it. So we're going into, or we are now in an era of essentially reducing interaction with the system and optimizing on site. And in a way, this is positive, because we're developing all sorts of very intelligent technology options that consumers are installing on site. But we could do so much more if we actually encourage consumers to not only use this to optimize on site, but to actually interact with the system and contribute this flexibility there also. And I think this is the big step that also regulation has to follow now. And we've started. I mean, in Europe, we have started with the adoption of the so-called clean energy package early 2019. That is currently being implemented. But I think some important changes that this brings about is that, at least in principle, all these decentralized flexibility resources, be they the way we operate renewables, be they storage, or be they demand-side flexibility, demand response resources, they should all, in principle, be able to access all European energy markets. Access them either by what we call explicitly offering their flexibility on the markets, which is usually done via service providers, via aggregators, who work with the consumer side, who bundle the flexibility and as a pool offer them to the energy system and valorize them. And this is something we have seen starting, and it's already quite common with many industrial areas to do this and offer this. We're seeing it more now in the commercial, and in some countries even in residential, where the regulation allows for it. And this is what is going to and has to come a lot more, as we also see more electrification of heating, more electrification of transport, that this is becoming increasingly important. And then another dimension, so I mentioned this explicit offering to market. Another dimension is what we call implicit, which means the consumer receives the price signals and reacts. So if a consumer can choose dynamic price signals on energy, reflecting the variations that happen on the power market every 15 minutes, then the consumer will, by help of automation usually, have an incentive to also adapt their energy use or their actual feeding in of energy to the system to these price signals.
I mean, that would benefit even me, like as a personal example. I mean, I'm a tenant, just such as 55% of people in Berlin or in Germany. And the only thing I can really control is when to put on my washing machine. But it would be amazing if, that's a very practical example that you kind of started. If I could say, okay, now it's daytime, I'm in home office working from home, and I can do my laundry now. And I don't have to wait until the evening when there's maybe no wind or there's definitely no sun anymore. But I could use my washing machine now where we have sun and it would be a little bit cheaper. I would be happy to do this. Or of course, if I have an app that tells me, hey, the electricity prices are really low right now because the sun is shining. Why don't you think about doing your laundry? Something like this. And maybe coming back to what you said, what are the policy challenges? You started mentioning something that I was thinking about preparing for this dialogue, which is that we're really, really lacking data. And this is first one of the biggest challenge of digitalization that we're facing for energy efficiency. And second, it's also, I think, the most important thing that policymakers should focus on, because policymakers always have to be careful with pushing money around. Yeah, it's all taxpayers' money, and you always have the risk of incentivizing the wrong thing with different kinds of subsidies and so forth. But what we do need is more transparency. We're only starting the smart meter rollout for electricity use this year. And I think we need the same thing for the heating market or even for the cold market, that we gather how much electricity and how much heat is actually produced and consumed at a certain point of time. Right now, we only either use simulations and models to kind of estimate our energy consumption, or we use it in laboratory experiments. We build a house somewhere and we measure it and we pretend that there's a family living there for a month, and then we see what comes out. But what we don't have is a system that says, okay, we need heat right now, so then it's only produced, or electricity. So I think we really need to get the data first to know where we have to put the right incentives. By the way, there's one nice example from the German policymakers that tries to find a solution for this, and I think it's really good example. It's called Pilotprojekt Einsparzähler by the Ministry of Economics in Germany. And what it does is, it's not a broad subsidy, but basically the ministry says, hey, if you're a company, an organization, we give you a subsidy per every proven saved kilowatt hour of energy if you give us a business model and show us your methodology and how you measure the data. And then we give you a subsidy for every kilowatt hour that you were able to prove that you saved it. At Termondo, we've actually applied for the subsidy, so now we're waiting for our subsidy approval, and then we will start with a modeling process where basically we will go to a customer if they want to take part in this project. We will install heat meters next to their heater, next to their warm water, and then we will measure their heat continuously and see how they behave, how the weather plays in, how the season plays in. And then we will get a subsidy for this. Part of the subsidy we will give to the customer, and part we will optimize this thing. So at some point, maybe we don't have to give a lump sum subsidy of 5,000 euro to every person who buys a solar house, a solar heater, and we don't even know if it's efficient, if it's being used, if the person actually needs the subsidy or just gets it because he has money anyways. So this will improve the entire efficiency of policy making, I think.
You say there improve efficiency. What else? And you talk about needing data. What else? What else we need to do, or what are other steps that we need to take to improve efficiency in terms of data analysis, in terms of data gathering? What about action, something like automation and interfaces? Can you speak to that?
Yeah, maybe if I start on that. Picking up on the automation point, today most of the automation systems, if we look at the energy management systems in buildings, are very much built to optimize on site, and that's a good thing. And it helps usually for energy savings. It helps comfort in the building, amongst many of the other dimensions. Many of these systems today are not really taking into consideration the outside world. They're not able to take into consideration price fluctuations in the energy market. They're not able to take into consideration opportunities to, for instance, offer energy on the balancing market. But this generation of new energy management systems is developing, and this is one of the dimensions where we need to go with automation, to make sure that we can interact, or that technology can interact both inside the building, the premises, the industrial side, as well as outside. And that, of course, means that we need the whole chain of communication. So it needs to be the energy management system recognizing what the potentials are, but it also needs to be the outside energy world transmitting the signals. And it's quite easy when we talk about what I described earlier as explicit market participation, because then it's usually service providers like aggregators, can be suppliers, can be independent aggregators, can be anyone really who operates in this business, who identifies what the markets are doing and what is needed at that moment, and who interacts with the building or whatever the consumer side is to optimize and bring this to market. The other dimension of bringing the price signals to the consumer requires more and new types of digital transmission of data to make the consumer able to see what the price signals are, and not just the consumer, but the consumer's devices. Because I think Johannes mentioned an important example earlier. If you receive a text message, hey, electricity is cheap right now, why don't you do your laundry? And I think that's a good one. And that will probably work with a large number of people. And yet, I think as the system gets more complex, as we have more devices, we don't want to be bothered all the time to think about what am I doing now, and is it a good time to plug in my electric vehicle or is it not? And so automation needs to take over. All I want to set is, which range do I need my vehicle to be able to do? For instance, I always want to be able to do 20 kilometers no matter what, because who knows, there might always be an emergency. But for the rest, my automatic system can do with my vehicle whatever. It can discharge, it can charge, as long as I have my conditions set. That could be, so it needs to be automation, and this data needs to be transmitted, obviously.
Talking about this car, I just had another idea. The next step of this, and we will see this within our lifetime, is not just that I can say, okay, I want my car to drive 50 kilometers every day because that's how much I need to get to work and back and to pick up my kid from school or whatever. And with the rest of the electricity, I use my car as a battery for the system, right? But the next step would be, hey, I'm not using my car for 70% of the time. Why isn't there an app that allows somebody else to take this car, and then this car drives there, and then the car picks this person up by itself, and then they can use the car for a few hours. So we combine car sharing with efficient electricity use and with actually stabilizing the grid. I think we're going to see this kind of stuff within our lifetime. And maybe one more example from a specific company, Fresh Energy. They're also here in Berlin. They're a startup. They're doing something really cool. Very simple. They're only looking at your electricity consumption, just a load profile, how it goes up per day, per week. And from that, they can tell you which devices in your house are consuming a lot of energy and what is working quite well. They have built an algorithm that is looking at the load profile, how it moves up and down per day, and they disaggregate this data, and this algorithm gets smarter and smarter every day. And then they see, okay, you probably have a base load because that's your fridge, but based on your house size and whatever, and of the amount of people, actually, you consume a little bit too much base load. Have you checked if your fridge is maybe too old? Or there's a peak in your load profile. Oh, that might be the washing machine, but the washing machine consumes for 50% more electricity than an average washing machine from our other customers. What do you think about this? And then you have other stuff in the heating market like Tado, where very simple. They have smart thermostats that only turn on when you actually enter the house. So when your GPS from your phone says, hey, I'm home now, only then the heater turns on. Or it learns, so after a while it knows, okay, it's Monday, it's 5 o'clock, in 1 hour Johannes will be home, let's turn on the heating a little bit more. And then at some point this will integrate with the electricity market as well. So there's a lot of cool examples where we're already going in that direction, and where startups especially find solutions to all these problems, even though we don't have enough data yet. So I'm optimistic about technology having a positive impact in total on energy efficiency.
So we bought a new dishwasher a couple of years ago, and we always run it at night after dinner. And we use it on the eco setting, and it's somewhere between 3 hours and 8 minutes. And I think the longest it ever was 3 hours and 34 minutes. And we're confused, who's this talking to? And I love the idea of being able to do laundry while I'm away during the day. But if we think about this, not just in the home, what about in public spaces? Even larger scale, what about in industry? Frauke?
Yeah. Yeah, and I think this is where the potential is maybe even more obvious, because we're talking about very different scales. And maybe starting with the still smaller scales with the public spaces. A number of universities, especially in Great Britain now, are participating in the energy market, basically through the optimization of their heating, ventilation, and cooling equipment in the building. And they are cooperating with aggregators who valorize the flexibility that their heating, ventilation, air conditioning can offer, to basically bring that flexibility to the system and support national grid and support the British power market. And essentially what the university does is they set the criteria. This is the temperature range that we need. And then for the rest, they don't need to worry, and the aggregator makes sure that this temperature range is always met. But it may be, for example, that there's a lot of energy surplus at midday. So in the summer, they cool the buildings just to the lower end of the range. Say the range is between whatever, in the summer between 20 and 22 degrees, they cool to 20, so that they have a bit of buffer, that when there's a power shortage later, they can allow the building to warm up to the upper scale of the comfortable range. To name just one example. So it's universities in Britain that already do that, supermarkets as well, by the way. So for instance, Sainsbury's supermarkets in Britain have equipped, I think it's more than 200 of their stores now to interact with the system directly, again, through heating, ventilation, air conditioning. And then when we look at industry, it's maybe even more obvious, because we're talking about such large quantities, whether it's aluminium smelters, whether it's industrial cooling, where you have a lot of buffer capabilities. Or an example I always like is, I'm based in Belgium, Viwaqua is one of the Belgian water treatment companies, and they also engage in shifting their pumping and water treatment activities, because it needs to happen every 24 hours. They need to pump, they need to treat their water, but it doesn't really matter at what time of day it happens. And it's all done via machines anyway. So they also joined the pool of an aggregator who optimizes when their water treatment and pumping happens, in line with the electricity market's needs and capabilities. So these are some examples. And there are many, many more. I mean, also when we just think of the backup capabilities that many industrial sites are having, many of them using batteries. In the past, it was generators, which are probably not the cleanest and best option anymore, but they are more and more moving into also cleaner solutions there. These can be activated as well to support the system, especially for very fast frequency control measures. So yeah, there's lots of elements that are there. And yeah, I started off with aluminium smelters and these kind of very large applications that we're only basically scratching at the surface at the moment with what's participating in the market. There is so much more potential to be leveraged. And actually, to bring in some numbers, the European Commission assessed a bit on what's available, and they assessed that already today there's some 100 gigawatts of potential for demand response. So not including storage or anything else, just demand response in Europe's system today. By 2030, they assume 160 gigawatts. That could, in theory, be untapped. So 160 gigawatts in terms of capacity, that is basically roughly twice as much as the entire fossil installed capacity in Germany. So just to give you a size of, or an idea of the size, very roughly. And of course, that this demand response capacity, some of it is very fast starting, some of it is slower, some is available for longer durations. It's very versatile, and it's an enormous resource to help us balance an energy system that is becoming more and more variable.
I just wonder whether we managed to get the the two industries there that are not there yet. So that has to be electrified still in order for this for this area still to work, which is the building area, heating, cooling, especially private homes, because they're hugely heterogeneous and very different to each other. And of course, transport as well, just because, I mean, the industry, especially in Germany, we're all, despite the hype for electric cars, we're still very much locked into fossil fuels, gas and diesel cars. So I just hope that we manage to bring these industries there as well. And then we have big international stuff like huge container ships that probably won't use electricity for a long while. How do we achieve efficiency and less CO2 emissions in that area through digitalization? This is always a question that I ask myself, and I don't really have a lot of answers yet.
Johannes, you mentioned I want to pick up on the first two, on the heating and transport. I mean, I entirely agree. These are essential and huge dimensions. If we just look, we've done so well for the energy transition. If we look at electricity, yes, we've seen a very tremendous renewables uptake, and it will continue and it must continue. But electricity is only around a quarter of the total energy we consume. And heating and transport are such a large dimension, industry as well. If we want to decarbonize and continue with the energy transition at scale, then we need to electrify a very large part of these sectors. And I even think, I mean, you said you hope that we will manage to do this in a smart way. I think we can't even not, because if we electrify transport and we just do it in a random manner, and everybody gets home, plugs in their car at 6 or 7 in the evening, exactly at the time when the sun sets and solar power is no longer available at that scale, the system will simply maybe not collapse, but if it doesn't, then we will have to invest a large amount in backup, in grids and everything else. So we just have to make it smart. And I think the best way, and Johannes referred to that earlier already, the best way to do this is to get ready now with the technology. So to already make clear that all charge points for electric vehicles allow for smart charging, to make sure that the building renovations take into consideration both the electrification, but also the smart interaction of a building with the energy system. We're talking at the moment as part of the European Green Deal, and especially now also with the whole recovery discussion, about a renovation wave in Europe, really supporting the fundamental renovation and refurbishment of homes and buildings. The moment is now to think ahead and think of the energy system we're moving towards, and making sure that these buildings can be powered with renewable electricity and can interact with the system to support the energy system. Because naturally, transport and heating are such good buffers. Especially if I have, well, transport, we talked about it, it's obvious, it's a battery on wheels within certain ranges. Well, the consumer needs to set how much the electricity or the car needs to be loaded by which time, but for the rest, battery on wheels, a home or a building becomes a battery also, especially if it's well insulated. Exactly. If, for example, the home can already heat up in the afternoon when the sun is still shining and electricity is available, or at any time when the wind is blowing, for it to be warm and ready and nice when I get home in the evening and I want it to be comfortable, then it's entirely possible if my building is well insulated and it can keep the energy and the warmth for a couple of hours, and it becomes a perfect buffer.
That's not just the building heating, but I mean, I think 2/3 of the energy we consume in our homes is actually the warm water. So for that, you just need a big warm water tank. Where we get to challenges that a warm water tank in a lot of houses doesn't even fit because it's very big or because the door is too small. This is speaking from practical experience. So those are different challenges, not really related to digitalization that much. But yeah, this is a huge thing. A house can be like a battery for heat. And there maybe we go to a topic that that I don't have a final opinion about, which is the entire hype about hydrogen. So we have hydrogen, which can serve as a very big, has a very big chance for creating more flexibility and enabling us to use renewable electricity in different sectors as well. Because, for example, if we have too much renewable electricity, we use electrolysis to convert it into hydrogen, and then we can use that either in the transport sector, even in big ships, something like this, that right now use on very heavy oil, or that we can use in a gas condensing boiler in a home. So as use as like a green gas afterwards. This way we can use again electricities in some way where we haven't been able to use it before, or where we even had to regulate the market, or in Germany, give away our electricity for free to our neighboring countries. But on the other hand, with hydrogen, and I wonder what you think about this, I've kind of felt, at least in the German discussion for the last couple of weeks and months, there has been a hype that, especially from the industry, that has been not very critical. If I read about hydrogen, everybody talks about the huge chances that it can give, but I don't see hydrogen being the solution for all our problems um, if we use this in the industry instead of the areas where we actually need it, for example, transport or the building area. What does it look like in Brussels? What's your perspective on this?
You spoke about a hype, and I think to some degree we see the same kind of hype in Brussels as well. I think, I mean, looking at it, it seems so nice, so easy. We just transfer everything into hydrogen, and we can basically keep going as we did. We don't need to change behavior very much. We still use combustion engines. We still use power plants as we know them. Unfortunately, there's one really big caveat, and that's the efficiency.
Exactly.
I mean, it's just transforming all this electricity into hydrogen and then burning it again means we're losing so incredibly much energy that all of this becomes a lot more questionable. And so I share your reservation about hydrogen. I think we do need hydrogen. I mean, I want to be very clear. We do need hydrogen for processes that cannot be electrified directly, or where electrification is just not realistic. And there, hydrogen is a beautiful resource. It can also serve as an interesting buffer, including a seasonal one. It can serve for processes where no other solution is possible. But where direct electrification is possible, it is just so much more efficient. And as we discussed basically over the last, I guess, half hour or so, this direct electrification offers enormous flexibility potentials in itself as well to buffer the system. And the beauty of it is that this direct electrification we talked about and the flexibility it brings is even very fast flexibility, very often flexibility that can be activated within a matter of seconds or even milliseconds to be there in the system when the system needs it and when fluctuations happen.
Yeah, we will definitely see still a lot of things going on there. So I don't know whether we're going to talk about the risks or challenges of digitalization for energy efficiency later on, but hydrogen would be one of the topics that I would mention when we talk about this, because
I think now is later on. Let's talk about it. Let's
so
talk about the risks and challenges.
So, I mean, chances and challenges, chances and all the profits of digitization are very important. But I've also been thinking about the risks and the challenges. And I think probably the biggest risk, because it's most underestimated in my mind, is that we think digitalization or technology will save us from the climate crisis, and we don't have to do anything anymore. Frauke, you just mentioned it as well. We become lazy, and we think we don't have to change our behavior or change our total energy consumption, because everybody thinks, and I have to admit both the startup industry and policy makers present this more and more often, or still too often, where we say technology will save us all. We don't have to reduce our consumption. And if we don't realize this, at least, then I think we will not tackle this global crisis.
Maybe, yes, I mentioned that digitalization means we don't need to worry about our energy consumption every second, in the sense that automation should help when is the best time to charge the electric vehicles and when to discharge. But I think that doesn't change the fact that, of course, we need to be as efficient with our energy use as we possibly can. I mean, especially, I mentioned earlier, electricity is just a quarter of our total energy use. If we want to electrify heating and transport in order to make them benefit from the renewables potentials in electricity, then just imagine the amounts of electricity that we will need if we're not using it efficiently. So clearly, I think efficiency is a precondition to everything, and that means also changing behavior towards energy use. I have no doubts about that. But I think beyond that comes the how much can automation and digitalization help us do this? Because getting people to worry about it at every second, I think, is a very good course and effort and endeavor, but I don't know how many people will actually be willing to do this. So it needs to be easy, it needs to be convenient, it needs to happen by itself, essentially, and that's where we need to go. But since we are on this efficiency discussion, I do want to bring in one additional dimension, because I mentioned efficiency is essential and is the backbone to it all. But there's always a bit of a tension between energy savings and efficiency on site and the efficiency of the overall energy system. And there may be cases when it's actually interesting to sacrifice just a tiny bit of efficiency and energy savings in the house, because it serves the overall efficiency of the system. And I mentioned the example earlier about an electric heat pump maybe heating the house 2 hours before I actually need it to be warm, because these 2 hours before we may have excess renewables generation that would otherwise be wasted and that would otherwise have to be curtailed. And in such situations, it does make sense to make use of this electricity to already run my heat pump, warm the house, even though it may lead to a couple of units, a couple of kilowatt hours to, or even less when we talk about an individual building. But anyway, a bit of energy to be lost, because it's not actually lost. It would otherwise have been curtailed. So important dichotomy here between energy savings in the strictest sense on site and system efficiency in the bigger sense. And in the end of the day, I think it's system efficiency that we need to care about, the sum of all the energy uses and energy options that we've got.
Yeah, definitely.
And it's, by the way, a very interesting political or policy development as well. We've seen now, at least at the European level, for the first time, that system efficiency, it's making its way into the conversations. The European Commission has just prioritized it in their system integration strategy. So looking into basically what in German is often considered sector coupling, the integration of heating, transport, industry, electricity. And there they've coined the term system efficiency and are looking into a strategy in this direction. So I'm confident that we will see more on that, and I think we've got to. It's a very, very interesting area to explore and work further on.
I mean, with system efficiency, I had those thoughts. Just two examples that might, well, they have to do with technology and digitalization as well. On an individual level, it's like, I mean, I just haven't found the data, or maybe there isn't some, or maybe I haven't just seen it yet. But what is more system efficient? Is it better to keep my 15-year-old TV and watch it there and get my paper newspaper and read that on the side? Or will it actually be more efficient to get a new computer with which I can stream Netflix when I actually need it or when I actually want to watch it, and buy a tablet that first has to be consumed with rare earths and rare minerals and whatever else somewhere else in the world, and then consume my media on this, a newspaper on this? And what's my personal benefit of this? Like, I don't know, watching YouTube on the tablet or reading a newspaper. It's a totally different discussion. But what's the system efficiency for an example like this? And then a second example would be if you take electric cars, and again, there has been this question, okay, now we use electric cars and we give them subsidies. And of course, once they use renewable energy, they are better for the climate. But what are the systemic costs of actually producing an electric car, especially the battery, like lithium-ion battery, upfront? In comparison with a gas-based car. So these are very specific questions when we talk about system efficiency that I think are also important for just the average citizen.
Yeah, and I think there, Johannes, you're even looking beyond the energy system efficiency that we may have in a particular country, but really at the complete lifetime footprint
exactly.
of products. And I think it's
globally, not just in Germany.
Yeah, and we have a long way to go to reflect those prices in the actual, whether it's via prices or other certificates or tracing mechanisms. We have a long way to go to take into consideration all of this, but it would be the optimal, of course, to do so.
I think so. Frauke and Johannes, I have to say that it has been really exhilarating to just watch the two of you talk with one another. I have to thank you both very, very much for making my job so easy today. It's been really exciting, and I'm happy that we touched on everything that we've had a chance to touch on. Before we say goodbye to one another, maybe just in a few words, just some final thoughts, how we can accelerate smart energy efficiency. Johannes, just a couple of words, perhaps.
As a society, I think when we look at technology and energy efficiency, we should first focus on transparency, on data, getting the technology there to actually measure where do we need energy, where do we create it, and to bring those two things, supply and demand, closer together. That's the second challenge. And then the third challenge is each on an individual level, but also on an organizational and on a country level, we have to ask ourselves, how much do we need technology to actually make our lives better? And at what point can we also reduce our consumption to tackle this climate crisis? We shouldn't ignore technology. We should not think that technology will save the world. It's each of us individually as well.
I absolutely agree. Frauke, your final thoughts?
Going into a very similar direction, maybe unsurprisingly. But I think in the end of the day, it's for every energy user to have the information and to have the access to what's going on in the system and in the energy market. And that means being able to participate and valorize one's resources in the market by help of a service provider, by help of price signals. So really having the access. And the second dimension is having the price signals, the revenues from it. So one is to be able to participate in the first place, but most users will do it only if it also if there's a bit to be gained. And I think in our world, it's usually expressed in prices. And if this is the way to translate the information, this is what's needed. This needs to be working, and currently it's not. So even if there is market access, very often price signals are distorted, either at the wholesale level because we have overcapacities, because we have various mechanisms that are hampering price signals because of whatever it may be, badly defined capacity mechanisms, other interventions, or at the retail level because of badly designed grid charges, taxes, all sorts of things that make it unattractive for consumers to actively engage in the energy system and contribute to a increasingly renewables-based variable energy system. So that's, in a nutshell, it's the access and it's the price signals that need to be right for people to optimize the energy use on site and in relation to the energy system.
Those are fantastic final words. Thank you very much to Frauke Thies and Johannes Kunert for joining me for the 6th episode of the Green Sofa Dialogue.
Okay,
ciao, ciao.
thank you. Bye.
Bye bye.